We continue the Math 4 Test 1 or Mastery Test, Module 5 Mastery Test Review. We're on 4b. This problem is k squared plus 2k plus 5 over k plus 4 times k plus 1 plus 5k plus 7 divided by k plus 4 times k plus 1. And you notice I have a common denominator here, which means all I have to do is add my numerators. So that means I have k squared plus 2k plus 5 plus 5k plus 7 divided by your common denominator k plus 4 times a quantity k plus 1. So here I need to collect my like terms, which gives me k squared plus 2k. Whoops, that's 7k, isn't it? Sorry, I didn't miss a like term there. That's k squared plus 7k. It came from 2k plus 5k plus 5 and 7 is 12 over my common denominator of k plus 4 times k plus 1. Okay, so this numerator needs to be factored. I'm looking for numbers that multiply to 12 and add to 7, which of course are 3 and 4. So that becomes k plus 3 times k plus 4. And of course the order that I write those in doesn't matter since multiplication is commutative, over k plus 4 times k plus 1. And now everything's factored. And I'm looking to see if I have any like factors in the numerator and denominator that I can divide out. And of course I have the k plus 4 in both the numerator and denominator. K plus 4 over k plus 4 is 1, so that divides out. And I'm left with, I'll go in this direction, that leaves me k plus 3 divided by k plus 1. And that is my final answer. Okay, the next problem, which is 4c, is a subtraction problem again. So the first thing I have to do is determine if I have a common denominator. The denominator of my first fraction is 4d times a quantity 3d plus 1. The denominator of the second fraction is 4d times a quantity 1 plus 3d. So what I'm trying to decide is, are 3d plus 1 and 1 plus 3d the same factor? And of course they are. The only thing different about them is their order, and since addition is commutative, I can add in any order. That's perfectly fine. So I already have a common denominator, which means I simply need to add my numerators. Keep forgetting to turn my pen on here. Okay, so that means I have 20d minus 9. I think I said add my numerators. Of course, I meant subtract my numerators. Minus 5d minus 14. Why did I put parentheses there? To remind myself that I was subtracting, so I'm not just subtracting 5d, I'm also subtracting negative 14, and I will have to distribute that negative into both things in my parentheses. That, of course, is over my common denominator, which was 4d times a quantity 3d plus 1. And I wrote it with variable term first and constant term second. But that is exactly what this is too. I just changed the order. Okay, so now in the numerator, I'm going to distribute that subtraction. And I have 20d minus 9 minus 5d plus 14 all over that common denominator of 4d times a quantity 3d plus 1. So now I have 20d minus 5d, which is 15d. And I have negative 9 plus 14, which is positive 5, over 4d times a quantity 3d plus 1. I'm going to move up to here. And now, if you recognize my numerator can be factored, there's a common 5 there, so I'll factor out 5. And that leaves me 3d plus 1 over the denominator I already had, which was 4d. times the quantity, 3d, plus 1. So now you can see I have like factors in the numerator and denominator. That's the 3d plus 1. I divide those out, and I'm left with 5 over 4d, which of course has no more common factors, so that's my final answer. Okay, our next problem, which is 4d, is 5 divided by 8 minus y plus 3 divided by y minus 8. And if you recognize that these two denominators are not identical, they're opposites. And they're opposites because the only thing different about them is their signs, and of course the order. But here y is negative, here y is positive. In this denominator 8 is positive, and this one 8 is negative. So the way you handle opposites is you factor a negative 1 out of one of them, and then they're exactly the same. So I'm going to factor negative 1 out of this one. If I factor out a negative 1, this becomes now negative y plus 8. I don't want that negative 1 to be in my denominator. I want my two denominators to be exactly the same. So I'm going to move it up and change this addition sign to a subtraction sign, and now make that just a regular plus sign in there, or really we have no sign there. So I just took my negative up to the numerator. So now I have y minus 8, excuse me, I said that wrong, 8 minus y in my denominator, which is a like denominator. So all I have to do is take that 8 minus y common denominator, and now 5 minus 3 in my numerator, because when I factored that negative 1 out, I moved it to the top so that both denominators would be exactly the same. 5 minus 3 is 2 over 8 minus y. Now, would it have been okay to change this one so that I had y minus 8? And the answer, of course, would be yes. I could have changed this one and brought my negative up here, and I would have had negative 5 plus 3, which would have given me negative 2, and I would have had y minus 8 instead of 8 minus y. Let me just show you if I did it that way. Okay, again, I started out with 5 divided by 8 minus y plus 3 divided by y minus 8. And I wanted them both to be y minus 8, so I took a negative out here. That makes that negative 8 and that positive y, which of course makes y minus 8, the same thing I have over here. But of course I don't want a negative in the denominator of a fraction, and I need both of these to be identical. So I'm going to take this negative and move it up to the front, and now that's a positive. So I have negative 5 plus 3 divided by y minus 8, which gives me negative 2 divided by y minus 8. And of course, these are actually both the same thing, because the only difference here is the signs on the two denominator values. And if I factored a negative out here and carried it to the top, it would make that positive, and it would make this what I had over here. So whichever way you chose to do it is perfectly fine. You could do it with your first fraction, or you could do it with your second fraction. Even though the answers don't look the same, they actually are the same.